Okay, so this is for lesson 4.2, solutions of systems of linear equations. I'm specifically going to be looking at the ones in the section 27 through 30, where we have some weird stuff going on with fractions. Now, I'm going to do problem number 28, and I want you to know that there's actually an easier way to do problems like this in most of the context where you will see problems like this, but that's not the point of what they're having you learn right now. So I don't want you to think that, oh my goodness, I'm going to be doing this all the time. You probably aren't, because most of the time that you have fractions, it's going to be set up differently. But if you, and if it's set up differently, there's much easier ways to handle it. But if you had something that was set up exactly like this, here is a way that you could solve it. So I'm going to show you the strategy that they mention and also how to implement it. All right, so they say, first off, you can write, they say as an example, you can write 2 over x as 2 times 1 over x, and so on and so forth. So let's copy that down here. Oops. Copy that down here. So on this problem, I'm going to rewrite it as 3 times 1 over x plus 6 times 1 over y equals 1. Okay. On this problem, I'm going to rewrite it as 3 times 1 over x plus 7 times 1 over y equals, I got space again, 2. Okay. So take a second, get that copied down onto your page. Now what we're going to think about is, if I were to solve for something here, what could I solve for? Well, notice that these guys right here, they're already very similar, right? They're almost opposites of each other. So let's multiply this top equation through by -1. And again, running out of space. Okay, so I'm going to rewrite this equation as -3 times 1 over x minus 6 times 1 over y equals -1. Okay, this is equation 1. This is equation 2. I don't want to mix up what's going on here, all right? Now I can add them together. Let me pause just for a second. All right, so you should have, this is going to cancel out, give you a 0. Then you'll have -6 times 1 over y plus 7 times 1 over y. And that should just give you 1 times 1 over y. So I can just write 1 over y equals, then you have -1 plus 2. Not too bad. Just 1. What do you do with this? So you'll need to use all of your different math, see what you can remember. I'm going to give you just a second to do that. Okay. There's a couple different ways that you can solve this, but if you know that 1 divided by y equals 1, the only value that y can be is 1. If you don't know how to get that, then you're going to want to watch this part. Otherwise, you can skip ahead a little bit. All right. How would you know that 1 over y equals 1, therefore y equals 1? You would say, okay, there's a couple different ways, so I'm going to show you probably the most straightforward way, but not the shortest. You could multiply both sides by y. Now, this is something that will change how many solutions you have in certain settings, so you'll want to still double check your answer in the original problem. Okay, this is a way that you can do it. You can just move him from being a denominator to the other side. Sometimes that's going to be the long way to do it, but it is a way that will always work if you just sort of follow the next math step, because then you'll say 1 equals y, and then you can use symmetric to say that y equals 1. There's your answer. If it was more complicated, it would have taken more steps. This one wasn't very complicated. Another way that you could think of it would be to say something divided by y equals 1. Well, the only thing, 1 divided by 1 would have to equal 1, right? Because if you were to do 1 divided by 2, that wouldn't equal 1. If you were to do 1 divided by 0.5, that wouldn't equal 1. There's not going to be another value besides 1 that if you were to plug it in for y would then equal 1 when you divide it. So there's going to be several different ways you can think about this problem, but you should get that y equals 1. Okay, for this problem, you could plug this value of y in to solve for your value of x if you wanted to. And I don't see any instructions from them saying, oh, you're going to want to solve it 2 different ways to get the variables. So let's just plug in that value of 1 into the original problem, which was, let's just pick the first equation, 3 over x plus 6 over y equals 1. Okay, so they wanted us to think of it as 3 times 1 over x plus 6 times 1 over y equals 1. And then you're going to leave this alone because you're plugging in a y value. We're looking for x. So plug it in right here. Oops, close my 6 off. 1 over 1. Oh, that's handy. Alrighty. Then you'll have 3 times 1 over x equals 6 times 1 over 1 is just, oops, not equals, that was a plus. Plus 6 equals 1. Okay. Then with a problem like this, it always starts to make me feel nervous because I'm just like, oh my goodness, what if I made a math error, right? So take a second, double check your math. I'm trying to draw on the page. Subtract 6 from each side. Just leave the unmanageable fraction multiplication thing alone until the last bit. Then you have 3 times 1 over x equals, what's 1 minus 6? That is negative 5. Okay. And then you are going to, again, leave it alone. Don't worry about the 1 over x. Just get the 3 away like you normally would. Divide by 3. And you have 1 over x equals negative 5 over 3. Okay, again, we are at a place where the answer is kind of obvious, but you need to know mathematically how to get it. So again, I'm going to show you the brute force way that will always work that's longer, and then I'll show you sort of the shortcut common sense way. Okay, brute force way. So we're going to multiply both sides by x, and again, this is a step that can dramatically change your problem because you're moving the variable via multiplication or division from one side to the other, which can do all sorts of things to signs and numbers of solutions. Don't have to worry about it in this problem as much. 1 equals negative 5/3 times x. Now we want to get rid of that fraction, right? Move him to the other side. So we're going to multiply by his reciprocal. We'll take the negative with him. We're going to multiply both sides by negative 3/5. Remember, you multiply by the reciprocal to get rid of a fraction. Then you end up with negative 3/5 equals x. Okay, that is a way that you can get the problem. We're going to pause for just. All right, now you're going to look on page 118 where it says to find x and y. Recall that if 2 numbers are equal, then their reciprocals are equal. That's the easy common sense way. So we're going to come back up here to this right here, and we're going to say, okay, if 1 over x equals negative 5 over 3, so if this over this equals this over this, then flip it. X over 1 should equal negative 3 over 5. Does that make sense? Does that seem rational, logical? This would be, obviously you'd want to write it as x equals, you don't want to put it with the x over 1, so you would say x equals negative 3 over 5. Okay, so that's your answer here. Now, to give the final answer for the problem, you don't give your x and y values independently. You give it as a point, right? So you say, oh, my y value is 1. My x value is negative 3/5. So my answer is negative 3 over 5, comma 1. This right here, this is my final answer. All right, hope that helps.